Okay, so good morning everybody. So thank you Bruce for the introduction. My name's Simon Wilding and I'm from Mercedes-AMG High Performance Powertrains, which are based in Brixworth, just the other side of Northampton, so some 40 minutes away. For those of you who don't already know us, we're responsible for the Formula One powertrain design, manufacture and testing, and we have a team of more than 400 people based in a technology centre in Brixworth. The focus is to supply powertrains for our works team, Mercedes-AMG Petronas, who some colleagues are already here today, and also 3 customer teams. So we have Williams, Force India and McLaren. Today, as Bruce has kindly already mentioned, I'm going to try and answer the question, will the new Formula One powertrain regulations influence developments within the mainstream automotive world? And to do that, I think first we need to go through a little bit of a history lesson, so apologies for taking you back to school. So Bruce kindly mentioned earlier that I've had some 20 years experience working in motor racing, so I'm feeling slightly old now, but it does give me some ability to comment on what's happened over that time from a powertrain perspective. So back in '95, the previously 3.5 litre V10 and V12 engines were downsized to 3 litre and V10. This is one of those engines, was actually internally inferred to as the FH, and it was a 72-degree V10. This actual engine was used by Mika Häkkinen that season to win the championship in, I think, '99. So then, after a period of just over 10 years, so over a decade, the regulations largely stayed the same from a powertrain perspective. And in 2006, the capacity of the engine was reduced to 2.4 litres in a V8 configuration. And this was one of the largest changes that had happened in the engine rules for a decade. And although I remember the discussions at the time, it sounds easy. Surely you just take 2 cylinders off the V10 engine and it just works. But I'm sure all my powertrain colleagues out there know it's not quite as simple as that if you actually want it to work properly. So lots and lots of challenges at that time. This shows the engine, so it's hopefully pretty familiar in the sport and certainly over recent years. In the season where it was first introduced, there were still no RPM limits imposed. So we were happily running the engine at over 20,000 RPM during the race weekends. And our development activities for the following season were revving considerably higher than that, a few thousand RPM higher, which is quite extreme and perhaps not so road relevant, but as we'll discuss later. The specifications of the engines at the end of the 2006 season were homologated, and we were allowed to retune the engine to meet a new RPM limit that was imposed, and that was 19,000 RPM. So that was a big challenge at the time. Next, in 2009, the RPM limit was further reduced, so down to 18,000 RPM, and we were also allowed the introduction of the KERS, or the Kinetic Energy Recovery System. So this engine is the FW engine, which raced in 2009. It was used by all of our teams, the base internal combustion engine. So that was used with McLaren, also Brawn GP, who thankfully won the championship with it that year, and our customer team Force India at the time. And this engine is proudly in display in our reception area that you can see here in Brixworth, and is actually very special because it's the first engine, a hybrid engine, that won a race in Formula One. So you can just see down the bottom right hand side the small motor there, your 60 kilowatt motor from the KERS system, and again, so a world famous engine, first hybrid powertrain in Formula One to win a race. So very brief history lesson over, thankfully. But hopefully I think what you'll agree is for the last 20 or more years, the regulations have fundamentally remained the same. There's been no big tear up. It's been, let's drop capacity to try and manage the performance increases. And we've had the enabler of KERS being introduced just at the end of that period from 2009. So what happened to the specific power within Formula One? So I don't think any of you would be surprised that power levels have gradually increased. That surely is our work topic for the last few decades, to have the most powerful engine. But more interesting is perhaps how that's been achieved over that time frame. So if you look at the general trends for RPM, or peak RPM over that period, trend to increase it up to the 20+ thousand RPM we were running in 2006, and then dropping down to the 19 and 18,000, which the series ended up being homologated at. Now, if we look at engine efficiency over that period of time, which hopefully you can just make out on the chart, there has been, of course, there's been gains, but nowhere near as large as the increases in RPM. So I think it's also fair to say that engine speed has been one of the biggest contributors to increasing performance and power of Formula One and race engines in general. So let's have a brief recap, and some of the guys touched on it this morning already, of what's important to my road car colleagues. So road car internal combustion engines are obviously being developed to be more efficient and to complement hybrid technology. So they're focusing on conversion efficiency improvements to reduce the CO2 levels, and that's things like downsizing, boosting, variable valve timing, friction reductions, direct injection, what else? I'm sure there's more. Exhaust gas recovery. So there's lots of different things which are all, let's say, commonplace in the road car development circles at the moment. So with that in mind, let's just have a quick think. Now we understand what's happened in Formula One powertrain development, and we know what's happened in the road car side of things. How relevant are they to each other? So the V8 engine, 2.4 litre, naturally aspirated, running at 18,000 RPM in its final guise. There's no limit on the fuel quantity used at that point in time either, and the injection, it must be port injected, so there's no direct injection allowed. The general development direction was for increased engine speed or high engine speed up to that point, which we've previously spoken about. The combustion chamber is very highly efficient in order to extract the performance, therefore a high state of tune, and lots of work is focused on minimising the friction. So although this particular engine was considered benchmark on the grid during the latter periods in the last years, I think it's fair to say that unfortunately it bears a limited relevance to the road car demand. But what about KERS? So does the technology align? Yes, it does. There's loads of cars you can buy today that have very similar technology to the kinetic energy recovery system, which is great. It can be used to harvest waste energy, and that's certainly the case on the road application. I'm going to say, unfortunately, that's not been the case in racing. So if we were to maintain lap time and use KERS, we could save 8 to 9% of the fuel load. But there was no benefit in doing that in the racing world, so everybody just used the performance to go faster, which was our mission to win the race. So is it relevant to the automotive CO2 reduction? Yes, I think absolutely it is, but more because the technologies are aligned rather than anything else. So the development of the KERS system was completed at Mercedes-AMG High Performance Powertrains in Brixworth. In the early stages, I think late 2006, early 2007, we started some development programs to look at the different technologies which could be used and which would be the most sensible and most high performing for a race car installation. We looked at flywheel designs, we looked at the electrical systems, we looked at lithium-ion systems, supercapacitor systems, and ended up focusing on the lithium-ion systems which we have today, which the majority of the grid have aligned on also. And through that whole learning experience over those years, I think when we started, we knew nothing about hybrid technology. We were a company that designed racing engines. That was it. And we've learned a lot, and we've brought a lot of that knowledge and learning and IP in-house. And that learning has been used on some road car programs, and Nick stole my thunder earlier on, but we have worked on the SLS AMG Coupe electric drive in the last years. So this vehicle is 740 horsepower and an amazing 1,000 Newton meters of torque, which I have to say, having had the privilege to try the car, is ridiculous. You just put your foot down, and that second, straight away, 1,000 Newton meters, and you're just pinned, and there's no gear changes. So you're pinned to your seat until you decide to back off. So you remember that experience very well. And so 0 to 62 in less than 4 seconds, and it doesn't matter whether it's wet or dry. It's four-wheel drive, torque vectoring, it just works ridiculously well. The range is around 155 miles, and it's also got the lap record for a production electric vehicle around the Nürburgring at just sub 8 minutes. And not only that, this vehicle is still the highest performing AMG road car that exists to date, which is quite amazing. And when you consider the battery was designed and developed at HPP, I think that's a massive achievement. So what was our role at HPP? What did we do on that project? So pretty much we did everything for the battery, start to finish. It didn't start like that. It started with AMG, our colleagues in Stuttgart, approaching us with a question. They really wanted to do an electric SLS. How do they do it? Could they use our battery experience to come up with a concept and give an idea of what targets could be possible for the vehicle? So we did a very quick, in a short time frame, as is usual in F1, a concept study, made a proposal to AMG about what we would propose to do. They also spoke to the normal tier 1 suppliers with the same topic, and contrasted our dreams, let's say, for the concept. And our work compared very, very favourably, some 20–25% higher from a performance point of view, and that may have come from our F1 background and our ability to take on risk. So AMG were very impressed with those figures, and asked us, they called our bluff really, and said, that's great, if you guys think you can do that, you should go away and do it. So we did, and the proof of concept was very successful, and the project grew very, very quickly over a short period of time for us to actually be responsible for the design, the prototype manufacture, the actual build, test, approval, all the validation and safety work which you need to do, all the way through to production, which is been complete for a year now, and to the after sales, which we're running at the moment. So a great program, and hopefully a very good example of how Formula One technology and the principles and know-how has been applied and directly transferred to road cars. So let's have a look at the comparison between the previous 2013 V8 engine and KERS and how that contrasts with the 2014 power unit. So we've spoken a lot about the V8 engine, 2.4 litre, 18,000 RPM, naturally aspirated. You're not allowed direct injection, and there's no control on the fuel flow rate. So that's known to us now. Now the new power unit is a V6. It's a 1.6 litre engine. It's capped to a maximum speed of 15,000 RPM. It's turbocharged, and we have the ability to use e-boost and e-turbine capability on that engine. It is direct injected, and there is a maximum fuel flow limit of 100 kilos an hour applied. So if you think about what's happened, it's been downsped, it's been downsized, it's boosted, and it's direct injection. Now all those things are big topics within the automotive world. So on that count, I think it's very relevant. So for the V8 and KERS program, we've mentioned there's no control on the fuel flow rate, but there's also no control on the fuel quantity used. You can use as much as you like. If it makes sense to carry 300 kilos, you could do that. Typically, as mentioned earlier, we'd use around about 150 kilos in a race, sometimes more. So there's no real control on the levels of CO2 that you'd be producing from that powertrain. Because if you compare that to what happens now in this season and what's going to happen this weekend, we're only allowed to use 100 kilos of fuel through the race, and that is a third reduction in fuel consumption, which is ridiculous. That's massive. And I think there's a lot of focus on noise and various things in the press at the moment with the powertrains, but if you just think, we've changed the Formula One engine, we've made a change in a ridiculously short period of time, just a few years, and we've got that running, and we've seen a 30+% improvement in efficiency and reduction in CO2 and fuel economy, which is, I think, amazing. So next, there's is the KERS. So KERS was previously a 60 kilowatt system, 400 kilojoules. You could use it for some 6+ seconds in the lap, and if you took it to its maximum advantage, you could probably gain 0.4 of a second per lap. So important, enough to make everybody want to try and get it to work on their car, but it's not going to change the world on its own. Efficiency gain from that system, as we've mentioned, because there's no control on the fuel quantity, so people just use it to go faster. Where if we contrast that to 2014, we have the kinetic motors doubled in size, so up to 120 kilowatts now. the usable energy is increased by an order of magnitude, so up to 4 megajoules, can be used for something of the order of 35 seconds per lap, which can give a 2-second per lap improvement in lap time. And as again mentioned earlier in the conference today, if it's not working, you really are going to pay the price on performance on the track. So it has to work. And combined with the kinetic side of things, you've also got the hybrid motor on the e-turbo. So we can recover something in excess of 20 kilowatts from that system from a turbo compounding point of view, let's say. So the other thing about the regulations which is useful to understand is that many items like bore size and crank center line, which don't really offer any efficiency improvements, let's say, are legislated, so they're fixed. So the engineers don't spend time thinking about that. They spend time thinking about how to make the engine more efficient and what technologies make sense, and improving the turbocharger and the e-boost system, which I think works very well. So what's the relevance of this power unit to the general CO2 reduction trend and requirements that road cars have? Well, I think it's very relevant, and that's not only because the technologies are quite aligned now, but also because there are fuel volume and flow rate limits imposed, and the focus is now very much on efficiency. So every conversation within my business is and what should we do for different developments is all efficiency focused. If you can improve that, then we're in a much better place. And we truly believe that the fastest car is the most efficient car, and I'm sure that's going to be demonstrated this weekend as well. So now the missions are fundamentally aligned, it gives many advantages. So one is the fact that other OEMs are surely going to be interested. So Honda are joining next year, and I hope other OEMs are going to be joining the sport soon, not only because I'd like to beat them with our power unit, but also because it's just good for the sport in general. Also, our board member, Thomas Webber, a board member of Daimler, has made the statement that he wants to make greater use of Mercedes-AMG HPP and use us for projects to do early development and prototype projects on the road car side of things. And I think our know-how that we've developed over the last almost 10 years now in hybrid technology and internal combustion engines places us in a very strong position to be able to do some of that work just up the road in Brixworth. So that's a great opportunity for us. So what does that mean for us? Well, that means we have an opportunity to expand the business. So there's discussions ongoing at the moment to increase the size of the facility and to start some recruitment programs and grow the business so that we can support our road car colleagues and working on those topics. And as well as that, we have advantages of trying to use the local supply base, which we've already got strong connections with now, but we can use that to put in very short periods of time have prototype systems up and running. That's the supply base that we've got around us in this area is expert at doing that, so we can move very, very quickly. And lastly, I think it's really, really great to think that let's say a small company just the other side of Northampton truly has the chance to change the direction of a very large OEM brand as Mercedes and the direction of all their future powertrains in the future, which I think is a really big deal. So let's go back to the original question I posed. So will the new Formula One powertrain regulations influence developments within the mainstream automotive? Sure they will, and it's already happening at Mercedes-Benz. Thank you.